Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you've been well and you have had, a nice, week or so. And everyone, welcome back into the program. We have, of course, today is the one, the only Mr. Ralph Bond. He'll be joining us here to talk about science and tech trends. And if you're confused of what that is, think about everything that technology kind of touches and, in some cases, just straight up science touches in our daily lives. And lo and behold, that's going to be near everything. So it's a nice grab bag, a nice mixed offering that Ralph brings us every single Friday to, lead us into the weekend with some uplifting news. And we'll get more into what that means. But with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, podcasts, reviews, anything and everything that Computer America does. You can find us there. Also, you can find our social media links or find our website through our social media links, whichever you, I know some of the younger folk, use social media as the internet. People, I think it's always fun, like watching, people talk about the internet and they're like, if it's not on Google, is it really on the internet? And it's the same way, I think, for younger people where it's like, if it's not on social media, is it really on the internet? And so, yeah, there you go. Everyone, before I get into back in my day stories, let's go ahead and get started with today's show. And again, it's our regular correspondent, Mr. Ralph Bond. He's been joining us here for quite some time and has evolved into our science and tech trends correspondent. And of course, Ralph, welcome back onto the program. How you been?
I'm doing great, and it's great to be back. And friends, if you're new to the show, we want to set the stage for you. What Ben and I do each Friday is highlight 4 recent articles that show us key trends in developments in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. Wow, you name it. Like Ben said, it's a grab bag, but it's all really amazing stuff, I think, and hope you're going to enjoy. And most important of all, we're going to give you an oasis of positive news. God knows we need that, thanks to the world of science and technology.
Absolutely. And I think story number 1 is really going to be there because one of the trends that we've been noticing either at CES or just in general stores that we do with you or just, the research that comes out. And one of them is like 3D printing and like organs and stuff like that. Cool, whatever. People need organs and it's, it's on its way, folks. But one thing that has, I think a lot of people excited is this idea of 3D printers, and not just that, but robots and autonomous things in the kitchen, or I think a lot of people who remember the replicator from Star Trek, maybe something like that in their lives. But anyways, getting 3D printers, getting food made, faster, easier, cheaper, more sustainably, whatever you have it. Robots and science and tech in the kitchen is always a really fun place to explore because there's so much research going on there. And you found some that, we may be looking at exactly that. Although this is, again, kind of getting to the replicator part. It's not just your traditionally 3D printed, pancakes or something like that. This is getting a little bit more futuristic. So story number 1.
Definitely more futuristic. This comes from one of my favorite outlets, The Cool Down, which you catch on MSN. And the headline here, this is why I jumped on this story, because this headline is so wild. Scientists use plasma to enable futuristic 3D printed food. Here's how it would revolutionize and industry. And again, friends, come out to computeramerica.com. Get what we call the show notes. The show notes are going to give you, if you're just listening to us as a podcast, this is very important. The show notes will give you the links, pictures, all this sort of stuff, so that if you want to dive deeper into each of these stories, you can, because what Ben and I are going to do is just give you the highlights. So with that said, let's jump into this story. Canadian scientists at the University of Alberta have found a new way to improve plant-based alternative to meat foods and other types of foods, and it involves plasma, the same stuff that makes up stars. And so with that opening line, I couldn't resist. I had to learn more. The breakthrough makes 3D printed pea protein hold its shape, opening doors for more affordable and tasty meat alternatives and, frankly, other food types as well. But I think the key here is meat alternatives. Ben, as you know, over the last several years, we have come across stories and developments where people are trying so hard to create meat alternatives, either by growing actual muscle tissue, replicating it on bioladders, as they call them, or racks and so forth, and forming alternatives to steaks and that sort of thing. But in this case, we're talking about taking vegetable material, pea protein, and improving its ability to be printed 3D in a form that's going to give us better texture and so forth to emulate meat. So that's kind of what's going on with this story. So again, this new technique helps 3D printed pea protein hold its shape. And side note here, real quick one, and in the show notes, I do a lot of injections. I add data that's not in the original articles to help you out and understand better the whole full scope of the story. So in this case, a little side note, pea protein comes from yellow peas. And to show you how not a foodie I am, I went, yellow peas? I know about the green peas we throw in the microwave, but yellow peas? Well, anyway, the pea protein comes from yellow peas. The process to create pea protein involves drying and milling the peas into a flour and then separating the protein from the starch and fiber. And in the show notes, I give you much more information about pea protein if you want to dig into that.
You even go as far as to give us the research paper that all this is kind of linked to. So, yeah.
There you go.
Yeah,
that's right. Again, that's why
Ralph,
the show notes are so important. Yeah. So pea protein is already in many foods we eat, from bread to dairy-free milk to meatless burgers. I didn't know. Now we do. It's cheap and packed with nutrients, but until now, and here's the problem, until now, it wouldn't keep its shape when pushed through a 3D printer, limiting its use in food production. So that's the problem that these researchers at the University of Alberta went after. And the research team solved this problem by mixing pea protein with a special water treated with cold plasma. Because at the beginning, if you thought about plasma, that's like incredibly hot. What are you talking about? No, this is something called cold plasma, a cold version of the superheated matter found in stars. Another little side note here, I had to do this to understand more, because when I read these articles, I went, cold plasma, wait a minute, what's that all about? So a quick little side note here, cold plasma, also known as non-thermal plasma, is a fascinating state of matter. Unlike the hot plasmas found in stars and fusion reactors, cold plasma has most of its energy in the electrons rather than the ions or neutral particles, making it not hot to the touch. And again, in the show notes, I have more on this if you want to learn more. Isn't that wild, though? Cold plasma. I didn't know anything about that.
I've never heard of that particular things, but yeah, and here it's used in so many different applications. Hey, why not your food?
Well, yeah, exactly. And so when the scientists ran tests comparing regular water to this cold plasma treated water for treating the pea protein, they discovered that using cold plasma treated water made the pea protein keep its shape much better, and it stayed stable longer after dispensing through a 3D printer. And again, believe me, anything to do with the food industry, which is, of course, massive and vital, and anything that can help create alternatives to meat. I'm not putting down anybody who likes the good steak. That's great. But there's a lot of people out there now, for financial reasons, health reasons, and otherwise, are looking for meat alternatives. But so much of the vegan or vegetarian meat alternatives are not that great. Now, there are some wonderful exceptions, but this technology that they've discovered in Canada is really going to help a lot, make a wider array of alternatives, plant-based food alternatives. Okay, so wrap this up here a little bit. These improvements in shape, retention, and stability resulted in improved 3D printing capability that will help produce plant-based foods with better textures and more interesting shapes, making meatless options more appealing to more people. So, big development. It may seem a little trivial, maybe, but this is big. The food industry, of course, is massive.
Yeah, and I think the image at the top of the article from phys.org, just kind of goes to show that if before you got this goopy, messy pile of pea mush before, and now you're able to print. For those who can't see, it kind of looks like an Eggo waffle. But obviously, this is just layers and layers of that protein that they're able to stack and hold its shape, and it's it's pretty intricate. Like, it's not like you're gonna eat a burger that looks like a waffle, but it's more so showing that you can hold the shape. So it's and all the reasons that you listed, as well as ethical concerns and whatnot, and just Ralph, it's from a technology point of view, doing the show for so long, seeing kind of what the trend is.
Right.
It's impossible to think that you're going to grow an entire animal through all of its stages of life just to cut it up into meat. Like, there's a way to jump to the part that you want that doesn't have the the cost, the ethics, the environmental impact. We are going to get there. It's just, are we going to get there in 5 years or 15, 20 years? Who knows? But that's definitely the way the trend is going. So,
well, yeah, Ben, in the world of food science, to kind of re-amplify a point we made earlier, there's two things going on. And one is growing actual real meat tissue in a lab on a large enough scale to make it quote unquote real meat, much less expensive. And then there's the alternative of the vegetable or vegan, if you will, alternative of creating things that taste, feel, maybe even smell like real meat, but they aren't. So there's those two trends, and both of those trends have an ultimate climate change benefit in terms of reducing the methane produced by thousands and thousands of cattle out in the field doing their thing and pooping and releasing issues into the atmosphere that cause global warming. So there's a dual thing going on in the world of food technology, which you might think is boring. Wrong. It's fascinating.
Right. It really, and it's like that for so many fields. I was like, sorry about that. It's like that for construction, for food, for boats and aquatics and whatever.
Yeah.
Transportation. A lot of fields that you think are pretty stagnant are actually moving very, very fast. And I think throw aviation off the top of my head. So, okay, ladies and gentlemen. Story number 1, you can of course find that in the show notes over at our site. We're going to jump on down to story number 2. And this article really, really piqued me as well when Ralph, kind of submitted it and I read it, because I even pulled up an article here. This is from Washington, and this is just one particular instance. Electric cars, they're cool. They're vastly improved and improving all the time.
Right.
They're going to become very common. Things happening aside, electric vehicles just make sense. And they're going to happen more and more as time goes on. And Ralph, I pulled this one up from May 2022. This article mentioned in Washington that they, I guess somewhere on it was a Lincoln Aviator hybrid that blew up on like the Clara Barton Parkway. No idea where that is, but they took the firefighters there. They did not have the proper equipment. They took 3 hours and 40,000 gallons of water to extinguish a hybrid car, not even a fully electric car that would have way more batteries, way more capacity. Ralph, it took 3 hours and 40,000 gallons of water to extinguish one electric car fire. That's a problem. That's a problem that's going to be going forward, and again, only going to become more and more common. That cannot happen. So, story number 2. Hey, maybe there's hope with some new technology. So, Ralph.
Yeah, this is a great one. It comes from an outlet I hadn't discovered before, and the outlet is Car Scoops. run together as one word, carscoops.com. And the headline is Koreans create EV battery, wait for it, that puts out its own fires, which is what Ben was referring to, and holds 87% of power after 1,000 cycles. But the key thing there is puts out its own fires. We've heard stories too, and I'm sure you have, Ben, those little battery-powered scooters that are so popular and that sort of thing, sometimes catching on fire. And that's very small-scale stuff, may not be disastrous like a car catching on fire, but this is a real problem. And the fact that they've come up with a battery technology that puts out its own fires if a fire occurs, irresistible. In the show notes, I have a link to the article, but I also have some other links as well that you can check out. But let's get into this. Recently, a team from, and I'm going to try not to butcher this Korean word, Tagu Gyeonbuk. And I'm guessing, guys, and you can come out to the show notes, get the real name of the institution, and try to figure out how to say it for yourself as well.
Yeah,
so this institution, of science and technology in Korea created an innovative new lithium metal battery that has a triple layer solid polymer electrode, and it's capable of extinguishing itself in a fire and retains strong performance even after many charging cycles. So once again, in the show notes, come out to computeramerica.com, I've injected a little bit about, well, wait a minute, time out. What is a triple layer solid polymer? Well, a triple layer solid polymer electrolyte is an advanced type of electrolyte used in lithium and metal batteries. It consists of 3 distinct layers, each serving a specific function to enhance the battery's safety, efficiency, and durability. And in the show notes, if you so desire, you can get into more and more details. It breaks down the 3 layers and so forth, but it's very, very geeky. But we'll move on here. In traditional solid polymer electrolyte batteries, lithium can form small tree-like structures called dendrites, 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 during charging and discharging. While the name might sound harmless, dendrites can damage the internal connections in a battery, significantly increasing the risk of fires and explosions. Well, we forgot to mention explosions.
Yeah.
This long-standing challenge has made it difficult to maximize the potential of lithium metal batteries until now. This is the key. So I have an optional side note once again in the show notes about what are solid polymer electrolyte batteries. So solid polymer electrolyte batteries, you can learn more about that if you so desire. The Korean team's clever design for their triple layer solid polymer electrolyte includes soft outer layers that ensure good contact with the electrodes, while a strong middle layer improves the battery's structural integrity. And the electrolyte is further enhanced with a fire suppressant decabromodyphenylethane. Oh my gosh, that's a mouthful. A high concentration, which in turn, by the way, is a high concentration of lithium salt, and zeolite, which bolsters its overall strength. While the specifics may sound highly technical, and they certainly do, the result is a safer, more reliable battery. And to wrap things up here, the innovation does not stop at fire safety alone. According to the research team in Korea, behind its development, the battery design boasts exceptional longevity, retaining approximately 87.9% of its performance after 1,000 charging and discharging cycles. And that's a significant improvement compared to most current batteries, which typically lose 20 to 30% of their capacity over the same number of cycles. And then to wrap things up here, a little reality check. The author notes it's unclear how long it will take for the innovative triple-layer lithium battery technology to reach mass adoption. And by the way, Ben, this reminds me to tell our audience, especially if you're new, that many times the stories that we highlight every Friday are things that are twinkle-in-the-eye research that haven't been deployed yet, but you're getting a sneak peek at what we hope will be a much better future.
Yeah, but for sure. And, the fact that this, and I'm sure the only drawback is adding, 1 or 2 more steps in the manufacturing process, but the fact that it improves so much and it's so well-rounded. And Ralph, I got to say, it may seem like, adding more cost to lithium batteries is not probably going to be very viable because it's like, hey, you can make a cheaper battery versus a more expensive battery. But I gotta say, the lower chance of explosion and fire, of course,
Yes.
the lower chance of explosion, I think we all saw what happened with, I think it was the Samsung S22 when that came out. And that thing, like they had to essentially recall every single Samsung S22 because it was exploding in people's hands and people's homes randomly. And Ralph, I could just imagine that, if you could ship these things by plane, that would probably be so much cheaper because right now you cannot do that with lithium batteries. So a lot of positives there. And hey, like you said with your reality check, we don't know how long, but if it offers that many clear improvements, it should not be long. It should not be long. So very cool story there. Story number 2, story number 3, and I like the way that the article starts out. The title, at least, I'll spoil it for you, but quantum computers that are actually useful, which is fun because, we've been talking about quantum computers on the show for some time. We had IBM on the show to talk about it. This is an area of research that's really been going on since like the 90s, I think, was when they kind of built their first rudimentary, quantum computers. Ralph, these things are like, just like, back in the 50s and 60s when they built the first computers and, you had people like standing inside the computer, switching up cords and stuff.
Oh gosh, yes.
And it really, quantum computers are kind of the same way. Like the entirety of, universities' basements are the quantum computer setup and they're still standing in there. Like we're at that level of complexity when it comes to quantum computers. It's advancing and it's very technically challenging. Don't get me wrong. I'm not saying that they're rudimentary. I'm saying that they're infant, they're fledgling. Well, story number 3, hey, maybe gets us, like it says, one step closer to actually useful quantum computers. So let's go ahead.
Oh, this is a fun one. And again, the whole world of quantum computing is such a hot topic right now. This comes from livescience.com. And again, the headline is Quantum Computers That Are Actually Useful and One Step Closer Thanks to New Silicon Processor That Could Pack Millions of Qubits. Well, there's a lot going on in just that headline, so let's try to break this down here. And by the way, just a reminder, back on December 27, at that show, we talked about Google's Willow quantum chip. And this news reflects the growing worldwide effort to develop practical quantum computing chips. This is the deal here. So this is why this story is so important. And let's first kind of set the stage with a quick reminder. A quantum computer is a type of computer that uses the principles of quantum mechanics to perform calculations. And unlike classical computers, which use bits as the smallest unit of information with values of 0 or 1, quantum computers use quantum bits, or qubits for short. And qubits, here's where things get weird. Qubits can represent both 0 and 1 simultaneously, thanks to a property called superposition. Wow. And for more, go back to the show notes for December 27. I have more information in there that we injected, but let's go on now to do the news. So, okay, now for the news. The author of this article opens with, quote, "We've just hit a critical inflection point on the road to scalable quantum computers, and here's why." So scientists say they have reached a critical inflection point, as we said a moment ago, after developing a technology that makes silicon-based quantum processors more viable. And the team responsible for this is an outfit called quantum computing company called Equal One, run those together, has created a quantum processing unit that can be built, and here's the key, using conventional semiconductor manufacturing processes. So one of the roadblocks for quantum computing is the exotic materials and other things that are required to make a quantum computer today. Wait a minute, they're saying, we figured out a way to make a quantum computer using conventional semiconductor manufacturing process. And this negates the complexity and expense typically involved with producing quantum processors using, as I alluded to a moment ago, exotic materials or complicated techniques. Ben, this is a big breakthrough.
So yeah, and I think for those out there who know their history, Ralph, of course, has some history with Intel, and I think he can tell you more than most that it's kind of fun that they're playing it up like just use conventional processor manufacturing techniques, and it's like, Ralph, there's few things in technology as complicated and as well finely tuned as manufacturing processors for computers. Like that is a very controlled, complicated, and very intricate process to make processors. So I don't know, it's kind of fun that they're like, oh, just use conventional stuff. Like they're going to go back to like stone tools to make these things. That's one of the most complicated things that you could do. But still, hey, if you could do it, way better, way better.
Yeah. And related, mixed in with this news story and this article, the company, again, they're called Equal One. So it's the word equal with the number one run together. Equal One. Check these guys out. Again, come to the show notes. We have the links for you. The company has also developed what the representatives called, quote, the most complex quantum controller chip developed to date. So that's related to this as well. And this controller, it can operate at ultra low temperatures and paves the way for millions of qubits on a single chip, meaning it can handle a huge number of quantum bits of information simultaneously while keeping them stable and accurate for calculations. And you might say, well, that's nice. So what? Well, wait, here's the so what. By contrast, the most powerful quantum chips today only house qubits in the thousands, not millions, thousands, and are built with superconductors, all requiring cooling to near absolute zero in order to perform quantum computations. Well, that's what's going on today, but these guys have come up with a way to use traditional silicon manufacturing processes. They can put millions of qubits on a single chip, and they can run it without having to have the near zero temperature situation. So that's why this is such a, drum roll please, big deal.
It's really impressive what they're able to at least claim to accomplish. And on their site, I was just looking at it, they have like a roadmap to 2030 and like research, but still they are on the right track. It's really incredible.
Right. And to your point, Ben, another example of early twinkle in the eye stuff here. We're not saying this is out there right now, but they're laying the groundwork, so to speak, to achieve this goal. And to wrap things up, Equal One representative said in a statement that, quote, combined, the new technologies pave the way for the next phase of quantum computing and demonstrate the fastest way to scaling is to leverage existing silicon infrastructure. Ta-da!
Makes sense. Very, very cool. So yeah, it's and ladies, I don't think we really explicitly said it, Ralph, but the advantage of all this, and like this is why we want all these people to succeed, is that this is the kind of thing that will help us with our crazy weather events, like snow in Alabama. This is the thing that will help us with medical research and finally being able to cure cancer. These are the breakthroughs that are going to vastly improve, like things that have vastly improved in the last 50, 100 years. This will make it improve just that much more, probably even more so. You talk about AI or, your lights turning on and off when you finally say turn off the lights, and it might actually do it. But no, this is going to help research and science and weather and all that tracking. It's going to make a huge difference. So I'm hoping anyone and everyone succeeds, because, that's going to be good for everyone. So there you go. Story number 3. Story number 4. Let's go ahead and wrap it up with, I say wrap it up because this is going to be a sleeve. We're going to wrap up today's show with a little bit of medical news, as Ralph likes to do. He takes the 4th story and dedicates it to medical news more often than not, really almost always. And it's a way to kind of show that, medicine, and there's few things as uplifting as, people who are dealing with loss of limb, be able to get a new limb. It's a way for, people with incurable diseases to, maybe even have a cure. Medical news is some of the best news when it comes to
Yes.
technology. And Ralph always dedicates story number 4 to that. So Ralph, let's go ahead and talk about, hey, restoring people's sense of touch.
Yeah. This is a really interesting story coming from Stanford University, their news part of their website. And I have some other links as well related in the show notes. And this has to do with something that could be applied to, I guess you could call it prosthetics. Let's say you've lost your hand, but you still have your forearm. We'll explain. You can see the picture if you're looking at the show notes and the video here. But again, if you're just listening to us as a podcast, please come out and get the show notes. But the headline here is new knit, as in knitting, new knit haptic sleeve simulates realistic touch. And we're going to explain what all this means. And this is a bit of a detailed recap, so bear with us, but I think it's so important. So wearable haptic devices, which provide touch-based feedback, can provide more realistic experiences, well, in things like virtual reality, assist with rehabilitation, and create new opportunities for silent communication. So there's a broad range beyond what we could say is related to prosthetics, but I still think this is so important. And I think really the world of prosthetics is where this has the most meaningful application. And a little side note here, in the realm of technology, haptics refers to the study and use of tactile feedback and sensations to interact with devices or control virtual objects. So that's what they mean by haptics. And that's Haptic.
Yeah.
Haptics. So
it's a very real quick,
yeah,
Ralph. It's a very kind of confusing definition at its face, but I think most people know it by, like, if you ever put your phone on mute and it kind of gives you like the double buzz or the single, double buzz for a text, single buzz for a notification. That's haptic. That's haptic feedback. So.
It is. It's a form of haptic feedback, and you also get that, like my old Xbox 360 game. The little controller. You can have a haptic. You can have a vibratory response when your car crashes or whatever. That kind of. It's sort of all related to haptics. So currently, most of these haptic devices rely on vibration, as pressure-based haptics have typically required users to wear stiff exoskeletons or other bulky structures. So there's your problem. Now, researchers at Stanford University Engineering Department have designed a comfortable, flexible knit sleeve called Haptinit. Haptinit, Haptiknit, Haptinit, that can provide realistic pressure-based haptic feedback. Their design, published last month in Science Robotics, and we have the link to that in the show notes, shows that pressure may be more effective than vibration for some applications and is the first step toward a new category of haptic devices. This is really breakthrough stuff. The senior author on the research paper about this, said, quote, "A device like this opens up a lot of new possibilities for user interfaces, how we experience virtual environments, how we experience remote communication. It's much more lightweight, wearable, and comfortable." That's the big key here. And the research team designed a battery-powered pneumatic system with pressure actuators that were essentially small, inflatable pouches that could be rapidly filled with air. But they needed a way to hold those pouches against the skin. They needed a way to hold those pouches against the skin without using a clunky exoskeleton. Right? Because you've seen so many prosthetic alternatives and so forth, the innovations that are great, but you feel like you're a knight in the Middle Ages wearing some big bulky thing, right? No, this is very lightweight. And one of the Stanford researchers, I think this is great, who makes clothes as a hobby, realized that knit fabric might hold the answer. I always love these things, Ben, when somebody has a related activity that may not seem scientific, but they can bring the techniques of knitting into this to solve this problem. Is great stuff.
Yeah. It's always surprising to a lot of people that Scientists are usually good at science, and engineers are good at engineering, all that kind of thing. Ralph, like some of the best breakthroughs happen when you get an underwater archaeologist mixed with a scientist, and it's stuff like it's seemingly unrelated fields that you get the breakthroughs. So
true. So it goes on to say here, the team designed a soft textile that would be stiff in some areas, creating an inflexible backing to hold the pressure actuators against the skin, and flexible where needed to allow for movement and control. Wow. The Stanford researchers worked with a team at MIT's self-assembly lab to manufacture the Haptic sleeve prototype on a knitting machine with space for 8 actuators arranged in 2 rows. And again, you just have to see the picture and the videos and so forth to really get this. Come out to computeramerica.com and get that information if you're listening to us as a podcast. Most of the sleeve was knit from nylon and cotton, but the areas backing each actuator also included thermoplastic fiber. Once the knitting was done, the researchers used heat to melt the thermoplastic fibers and cause them to harden, stiffen in those particular areas. And to wrap things up here, the researchers tested the Haptic prototype sleeve with 32 users. They found that people could more accurately discern the location of individual touches from the pressure actuators than from a similarly arrayed, in contrast to a similarly, boy, if I could say that on Friday, arrayed vibrational device. So this is a very interesting breakthrough. I think its key best use is for prosthetics, but it has many other wide applications. Lightweight, flexible way of having a haptic device on your body. Pretty cool.
Yeah. I could imagine these being used for like training athletes, and you put on sleeves on your legs and arms, and you can get like taps and different things, like subtle notifications that you can think about in the moment really easily, really quickly. I mean, Ralph, there really are a lot of possibilities with this. So, again, ladies and gentlemen, come out to the show notes. The article goes on and on and on about the possibilities for this thing, including, hey, you could even feel love through this thing. What that means,
well,
you can check out the article. Yeah, there you go. They're not that way, but in a different way. Hey, read the notes. Maybe in that way. Who knows? Go read. So with that being said, Ralph, that's story number 4. But ladies and gentlemen out there, if you're following along, because by the time that you hear this, the show notes are up and you have maybe been reading along, well, you run into the honorable mentions after story number 4. These are stories that are not worse, are not less. These are simply stories that we try to keep the podcast in a manageable time frame. And well, hey, here we are, honorable mentions, stories that just we don't have time for, but are still very, very cool. So Ralph, let's at least give them the headlines and they can come out to the show notes and get more information.
Yeah, very quickly here. This comes from sciencealert.com. Headline: Study reveals key Alzheimer's pathway, and blocking it reverses symptoms in mice. Wow. Okay.
They forget they have Alzheimer's.
So much research in the world of Alzheimer's disease.
Nice.
Oh my gosh.
Nice.
And let's see. The next one is from us, also sciencealert.com. Damaged hearts may have hidden self-healing powers, a new study finds. What? Self-healing. Okay. That's pretty cool. That's medical news, of course, so check that out. Next one from Popular Science, posting via MSN. Headline: How body heat could replace batteries in wearables of the future. Wow, wait a minute. Body heat replacing wearables in the future. Got to check that one out. That's pretty cool stuff. And our last one here from extremetech.com. Love that title. Headline: MIT physicists control magnetism with light. Extremely geeky, folks, but if you're a geek, check it out.
For sure. Yeah, it's and that even goes more so into technology, how they're saying it might even be a form of data storage. So hey, who knows? You never know. So with that being said, Ralph, we are going to go ahead and wrap up for today, ladies and gentlemen. If you want to find out more, again, computeramerica.com as always, and we have all of Ralph's show notes right there, and you can dig through that and find more information. But Ralph, I want to thank you so much for joining us here on the program. I want to thank the listeners out there for joining us here on the program as well. And until next time, do something fun, have fun, and ladies and gentlemen, it's all going to be okay. Let's go ahead and wrap this up and join us here next time on the Computer America Show. So until then, have a great day. See you then. Bye-bye, everyone.